Okay, hello ESN. This is homework #3, which is looking at direct and inverse proportion. So hopefully you've given the homework a go, and then you can use the video to help you correct and kind of go through anything that you're struggling with. Okay, so without further ado, let's begin with question number 1. That says this. Okay, so in this part, assume that each person works at the same rate. That is quite important to assume. And then it says 10 people can complete a job in 9 hours. Now I'm going to write the statement down straight away. So we've got 10 people, they can complete the job. I'm going to write it as a ratio here, in 9 hours. The question says, if 15 people work on the same job, how many hours will it take to complete the job? Now this is inverse proportion. If you've got more workers, the time should go down. So the more workers that you have, the time taken should decrease. Now to get from 10 to 15 might be a little bit awkward, but what could I do here potentially? Let's go and take this 10 people, okay, and let's go and divide it by 10. Let's get one person. So if we go and take 10 people and I divide this by 10, which means over here I've got to multiply this number by 10 because they're inversely proportional. So on the left hand side it's going to be one person. Okay, one person is going to take a time of 9 times by 10, which is 90 hours, which makes sense. If you've only got one person doing the same job, it's going to take much longer. Now I want 15 people, so I've got to go and get this one person up to 15 by multiplying by 15, which means that over here I've got to go and divide by 15. So 15 people is going to take a time of 90 divided by 15, which is equal to 6. So the answer should be 6 hours on this one. Okay. There we go. And that's it. So the answer should be 6 hours. I'll check the mark scheme in a second, but that is the first answer. Part B then says the following. Part of the same question. It says, in fact, of the 15 people, 6 work at a slower rate, 9 work at a faster rate. Okay. What does this mean about the number of hours it will take to complete the job? Now, because you don't know what rate they're working at, it depends how much slower the slow rate is and faster fast rate is. There should be an option that tells you don't know. Yeah, so it's not possible to say. It's the bottom one. Because you don't know, right? These 9 people might work at a ridiculously fast rate. It doesn't tell you. And these people might work at a ridiculously slow rate, or vice versa. You don't know how fast that rate is. It doesn't tell you, so you can't say. Let's go and check the mark scheme. So scroll to the end. Sorry guys, I've not got it with me. The first one is 6, and then not possible to say. Perfect. There we go. Question number 2 is the following. Let's have a look up here. Question 2 is x is inversely proportional to y. So straight away I'm thinking, right, how do I write this? Well, x, if it's inversely proportional, you write it being equal to k over your other variable, which in this case is just y. So which one is this going to be? X. So sorry, circle the correct statement. Okay, this is quite a nice question. Let's have a look. X is directly proportional to y. X is directly proportional to 1 over y. 2y. Well, it's definitely not going to be anything to do with a square root. There's nothing in there at all. There's sort of no 2 there. This statement, x is directly proportional to y, would be this, x is equal to ky. So it's not this one. It must be this one. X is directly proportional to 1 over y. Because they're saying here that k would be 1 over y. It must be this one. Okay, let's go and check the mark scheme for this one. There we go. That is correct. So that's quite a tricky one. Okay, so makes you think a little bit about it. But we can look at this one kind of going through a bit of trial and error. It's not the first one because that's the equation for this. There's no 2 at all in this up here. And that statement would also read, if x was directly proportional to 2y, it would be k lots of 2y. So it's not this one. There's no root in there at all. It must be something over y, which is what I've got over here. Okay. Question number 3 is 3 apples cost 96p. Work out the cost of 12 of these apples. So that's right, it's a ratio again. This one is direct proportion. The more apples you've got, the cost will go up at the same rate. So I've got 3 apples over here, and they're costing 96p. And I want 12 apples, so I want 12, which means I've got to upscale here by timesing through by 4 on this side, which means over here I times also through by 4. And I always think here, guys, without a calculator, just use a method so we don't make any mistakes. So we're doing 96 multiplied by 4, timesing 4 by 6 gives you 24, and 4 times 9 gives you 36, add 2 gives you 38. So that gives us 384p. Now the answer wants it to be in pounds, so just divide it by 100, giving you £3.84. Pence. And let's just check that one. Number 3. There we go. We can see that is correct. Perfect. Good. So there's the answer on number 3. And number 4 is looking like a best buy question. We've got this. 3 shops sell shirts. Shop A, Shop B, and Shop C. At which shop is it cheapest to buy 6 shirts? So also shirts. Now 25% off. Okay, sorry, you can see here, right? So on shop A, you've got 2 shirts, it's £19. Shop B, I was looking how many shirts there were, but there is just 1 shirt, and now 25% off. And a pack of 3 is this much here. Now, you want to get them all to be the same quantity. So in this case, 6. If I look at shop A to begin with, let's look at this one, shop A. Well, we know that 2 shirts cost £19. There we go. I want to get to 6 shirts, so I've got to upscale this by timesing through by 3, and I do that to both sides. So 19 times by 3 gives us £57 on this one. There we go. That's shop A done. Let's compare it now to B and see how much 6 is going to cost. Now, if 1 shirt is £12.40, but it's 25% off, okay, and this is without a calculator, okay, so to find 25% of £12.40, you can do this in different ways, but 25% is a quarter. So I can basically divide this number by 4. So to find 25% of that number, I can do how many 4s go into £12.40. You could find 10%, then 20%, and then 5% and add it all together, but personally, I'm going to choose this method. 4s into 1 don't go, carry the 1. 4 into 12 goes 3 times. 4 into 4 goes once, and 4 into 0 goes 0 times. So you're reducing this cost by £3.10p. So you've got £12.40, and you're reducing it by £3.10p. We're going to go and take these away, giving us 0, 3. I'm going to borrow this one, go to 0, giving us 9, and then 0. So this shirt is now for one shirt, it costs £9.30p. Okay. Again, I want 6 shirts, so I'm going from 1 to 6. Let's go and upscale this. From 1 to 6, we're timesing through by 6. Do the same thing over here. Go and times through by 6. So I'm now doing £9.30. Again, showing all of my working, £9.30. And we're timesing through by 6 over here. 6 times 0 gives you 0. 6 times 3 gives you 18. And then 6 times by 9 gives us 54. So £54.80 must be the answer. So there we go. £54.80p. So far, shop A is cheaper than B because 6 shirts is £57 and 6 shirts for B is £54.80. Let's now look at shop C over here. You've got a pack of 3 for this much. Buy 1 pack and get the other pack half price. So if I buy 1, that's going to be costing me 1. It's going to cost £37 and then 40p. If I buy another pack, I get it half price. So I've got to go and do £37.40 divided by 2, which will give us 2 into 3 goes once, remaining the 1. 2 into 17 goes. Goes 8 times, remainder once. And then 2 into 14 goes exactly 7 times, and then 0. So another pack is going to be costing. Sorry, this was a pack of 3, wasn't it? That's a pack of 3. Apologies. And another pack of 3, you get half price, which is going to be costing you £18.70. If I add those two numbers together, so £37 and then 40, add £18 and then 70. Let's add those together. Let's see what we get. 0, 11, 15, 16, 4, and 5 gives us £56 and 10. So all 6 shirts there cost £56 and 10p. So comparing all of these ratios now, we can see the cheapest one here is B. Yep, so we're going to go and say which one is cheapest, B. And you can see B is the cheapest, and you can see through all of my working that clearly this number is smaller than these numbers, and that will be sufficient. Let's just check the marking to make sure I've made no mistakes with the numbers. Yeah, it's looking good. I've got the same numbers. Oh, so it's looking like I made a mistake with this one, 55.8. What's happened here? 6 times 0 is 0. 6 times 3 is 18. Oh, that was silly for me. Over here, guys, I made a mistake. Sorry, 6 times 9, 54. I should have added the 1. Sorry, 6 times 0 is 0. 6 times 3 is 18. 6 times 9 is 54. Add the 1. Sorry, it should have been 55 there, guys. Sorry, that was my mistake. That should be 55 there. Okay. So this one, apologies, guys, should have been 55.80, but nonetheless, this number is still the cheapest. So B is still the cheapest, okay, because this number here is the smallest value. Okay. Good. That was a 5-mark question, a big question there. Question number 5 is this, which says a car will travel 60 miles. You can see up here. Draw a graph to show the average speed of the car for the times taken between 1 hour and 6 hours. You may use the table to help you. So 1 hour takes you 1 hour is 60 miles per hour. 2 hours is 30 miles per hour. Well, what's happening here is as you're doubling up here, as these are increasing by 2, these are halving. These are being divided by 2. It's inverse proportion. So from 1 to 3, what are we doing? From 1 to 3, let's get the pen back on. We're timesing here by 3. 1 times 3 is 3, which means I've got to go and do 60 divided by 3, which gives me 20. Okay? I can look at it, well, to get a 4, I can go from 2 to 4. I'm doubling, I'm timesing by 2, which means I've got to go and do 30 divided by 2, which gives me 15. To get a 5, I can go and think, well, from 1 to 5, I times by 5. From 60 to this one, I've got to do the inverse and divide by 5, which gives me 12. Okay. So now I can go and plot these values onto my grid. Time taken 1 hour, it gives me 60 miles per hour. So let's go and plot those as coordinates. So 1 hour gives me 60 up here. Okay. Then time taken 2 gives me 30. So 2 and then 30. There we go. And 3 and then 20 is going to go over here, and then 4 and 15 is going to go up here. There we go. And then 5 and 12, we're going to go. 5 and 12 is going to go here. Okay, quite hard to mark on my screen, but that should be good. 6 and 10 is going to go here. And this is looking good to me because this is an inverse proportion question, because we're multiplying and then doing the inverse operations, and we get this kind of curve over here. And you must make sure that you kind of plot in, and it's a freehand smooth curve because it is inverse proportion. And there we go. Okay, and that's your answer. That's your graph. Because it is inverse proportion, we know that the graph will take the general shape looking like this, which matches to what I've got over here. Okay. Question number 6. Let's zoom in. It says this. P, Q, and R have positive values. P is directly proportional to Q. So how do I write that statement? I write it as the following. P, if it's directly proportional, I put equals to a number K, Q. Okay, so P is directly proportional to Q. When P is 8, Q is 2. Let's just work out that first line to begin with. So I'm going to substitute in P to be 8 and Q to be 2 to find my K value. So P is 8 being equal to some value K multiplied by Q, which is 2. And of course, K must be 4 because 8 divided by 2 is 4. Therefore, K is equal to 4. So this equation is P is equal to K. I've just found out is 4. So 4 and then Q. There we go. The question below says R is inversely proportional to Q squared. Let's look at this one in blue down here. So let's look at this one down here. R, if it's inversely proportional, it's going to be equal to the K goes on the numerator over Q squared. That's how we write inverse proportion. So R is inversely proportional to Q squared. We then got when R is 10, Q is 3. Put them into the equation. So when R is 10, we get that being equal to our constant K over Q squared, or Q is 3, so over 3 squared. So 10 is equal to K over 9. To find the value of K here, we're going to do the opposite of dividing by 9 and do 10 times 9, giving us 90. So K is equal to 90. There we go. So now knowing this, I can put this back into my equation up here and say for this equation, I've got R is equal to my K value, which is 90. So 90 over Q squared. So I've got two equations. I've got this one and this one, okay, which will be useful, I'm sure, at some point. It then says, work out the value of R when P is equal to 0.5. Okay, so work out this value when P is... Now this is a bit more of a tricky question, okay? If you've got these first two parts, well done. That's really, really good. Now to work out R, which is this one, given P is this, well, in this equation, I've only got a Q, and I've got a value of P here. This is a bit more of a complex question. I've got to realise, well, I've got Q squared here. I want to have P somewhere in this equation so I can put it in. Okay. Now, if I rearrange this equation to make Q the subject, I can put it into this one. So this here is an equation. I'm going to go and make Q the subject by dividing P by 4. So I'm rearranging this to make Q the subject. Currently, P is the subject. Now I'm going to go and do P divided by 4. Let's give me Q. So P divided by 4. So now I've got an equation here in terms of Q. I'm going to replace this Q down here with this Q. I'm going to go and substitute in this in for this. That's going to give me R being equal to 90 over Q squared. Now Q is P over 4. It's going to be, I'm going to put it into a bracket, P over 4 squared. Now just by looking at this part over here, we could actually go and put in our value of P, okay, which is 0.5. That's going to do that. So now I've got R, which I'm trying to find, and P is 0.5. Let's go and put in our value of P. So R is going to be equal to 90 over, P is 0.5 over 4, and then squared. Now, 0.5 divided by 4, let's work that out. Let's write it as fractions. 0.5, I can write it as a half, so 1 over 2. I'm dividing it by 4, which is the same thing as 4 over 1. They both mean 4. So dividing fractions, keep the first one the same, change your sign, and flip the second one, giving us 1 over 8. Okay? So this 0.5 divided by 4 gives me 1 over 8, but I've now got to go and square it. I've got to go and do 1 over 8 multiplied by itself, which gives me 1 over 64. So now I've got R is equal to 90 over this part here, 1 over 64. So 1 over 64. Okay, So I've got 90 divided by 1 over 64, which is the same thing as writing 90 over 1. That means 90 dividing, I change my sign to times, and I write 64 over 1. Okay? And let's see what that gives us. That's going to give us a value of r for, what we're going to do now, 90 times by 64. Okay, let's go and do 9 times 64 and add on a 0. So 64 times 9 gives us 36. 9 times 6 gives us 54. Add 3, 57. But it's 90 times this is going to be 5760. Should be the answer. Okay, let's check the mark scheme. There we go, 5760. That is the answer. Now, guys, this, right, truthfully, that is a hard question. That is a difficult question that even students in year 11, at the prime of their abilities, they would find that really quite challenging. That is hard. Okay, so you might have to rewatch that a few times or kind of see me after class or whenever you can. But that is difficult. That is not an easy question. That's really quite advanced. Okay, but if you can kind of get the first part, which is to get the equations, that's marks in the bag. So if you can kind of get these parts up here, P and R, the rest of it was quite challenging. It was just a lot of, yeah, you have to be really on it with your number skills. But that is the answer. Okay, question number 7 says this. A stone falls vertically 300 meters above the ground. Okay, nice. So you've got a, let's just visualize it. You've got a stone being dropped 300 meters above the ground. There we go. The stone falls d meters in t seconds. D is directly proportional to the square of t. So D is directly proportional to the square of t. That means this. D is equal to, direct proportion is going to be k, and then t squared, square of t is t squared. That's the equation. The stone falls 20 meters, so your value of D is 20. So that's saying that D must be equal to 20 in a time of 2 seconds. So T must be equal to 2. Now, knowing this, I can work out the value of K in the equation. I've got D as 20 and T as 2. So I can go and say that 20 is equal to my constant value K times T squared, so 2 squared. So 20 is equal to 4K, and then divide the equation through by 4, giving me K is equal to 5. So my equation replacing this K value with 5 is going to be D is equal to 5, and then T squared. The question says, work out the total time taken for the stone to reach the ground. Now, I've got my equation here, which is really useful. By the time it reaches the ground, it's got to travel the 300 meters, which is saying that D must be equal to 300. And I want to work out in the question the time taken, which is T. I've got to go and find this out now using my equation I've just got. So I replace D with 300 and say that 300 is equal to 5 times T squared. Now, to get this 5 on this side, because I'm trying to find the value of T here, let's go and divide everything by 5. So 300 divided by 5 over here is equal to T squared. Now 30 divided by 5 is 6, so 300 divided by 5 is going to be 60, so 60 is equal to T squared, which must mean that T is going to be equal to the square root of 60. Now this is a calculator question because you can't work this out without a calculator, or not very easily anyway. So root 60 gives us plus or minus, but can be positive because we're looking at time, can give us an answer of approximately 7.7 seconds, and I've rounded it to 1 dp. Now what you round to is up to you because the question doesn't specify, but the answer is 7.7, and that should be the answer. Let's go and look at the mark scheme. There we go. So anything between 7.7 and 7.75, just depending on how you round it, is fine. And that, guys, is the end of the homework. Hopefully that was useful with the video solutions. I would say question 6 in particular was really quite challenging. Question 7 was also probably, you can do it, but it's just, exam style questions. They take time to get used to. It's just practice with exam questions. But hopefully the video was useful. And if you enjoyed the video or you found it useful, I'd really appreciate it if you can give a like, or you can always comment, or just a like would be really appreciative. I'd be really appreciative of that. Anyway, guys, have a good day and keep up the good